In this video lesson, I'm going to explain how to answer qualitative analysis questions in practical exams. Here, I'm going to tell my learners on how to tackle qualitative analysis questions. Here, we are going to be dealing with inorganic and organic compounds. In the examination, you are going to be provided with unknown compounds. They could be salts, they could be liquid or solutions, anything of that nature, which are unknown. Examiners, they will usually label them. It could be FA1, FA2, FA3, not to give the identity. You are now left to identify them. A number of tests are there that you are going to carry out. You have the cation test for the cations, the test for the cations, and the test for the anions. You have tests for the gases. You have a test for the carbonyl compounds. Your functional group, organic functional group, of course, which there are many of them. So there are many other tests that you are going to carry out. So I advise my learners to be very critical and sharp in observing results results of any test they are doing. For instance, we are going to start with, let me say, the cations. The cations, remember that in every question paper, you have a confirmation page, or what we call a reference page. That reference page has results of the different tests for cations, for anions, for gases, for functional groups. When you are carrying out your qualitative analysis, it is always advisable to always refer back to your reference page to know whether your results do tally with the results on the confirmation page, where those results are displayed. So now, if you are to start with the cations, what we are going to do now is, remember, in a test tube, you have a solution, you have an unknown salt. If you put the unknown salt into the solution in a test tube, while it may require some warming, if it does not even require warming, immediately you observe, let me say, fizz or effervescence or bubbles of gases. You can state them like that: fizz or fizzing, bubbles, effervescence. All those ones, when you observe them, make sure you put them on your answer script, that section of the answer script under observation. Mention them like that. And automatically, when you see things like, when you are dealing with cation, when you see things like there's fizz, there is effervescence, bubbles of gases, what comes to your brain is that a gas is being released. And the next thing, as a good student, what you need to do is test for the gas immediately. A good knowledge of, in doing that, a good knowledge of your lithium, a good knowledge of your litmus paper is required. Whether to test whether the gas is acidic or is alkaline. If it turns blue litmus paper red, it's acidic. If it turns the litmus paper blue, it is alkaline, like in the case of ammonia. So you have to test the gases. But if you notice that it is an acidic gas and what should be coming to your brain maybe is carbon dioxide. It has to do with carbonates. It has to do with carbonates. You know, carbonates, when they react with dilute acid, what is a salt? It is carbon dioxide and and water that is usually produced. So in that situation, you need to test. If you notice that it is a carbon dioxide that is being released, litmus test. Lime water is usually the test that is used to test for carbon dioxide. If you test for the and you use the lime water to test the gas, and you realize that it turns lime water milky, then that's a confirmation that it's a carbon dioxide gas that is being produced. Or white precipitate are observed, that is a confirmation. Or light yellow precipitate observed, cloudy situation in the test tube, just know that it is a carbon dioxide gas that is being produced. All the observation, once more, must be stated on the answer script, on that observation section of the answer script. Should in case you notice that there were precipitate that were formed when it has to do with cations, when there were precipitate that were formed, test their solubility at excess of the solution. If they dissolve, okay, mention them there and refer it back to your reference page where the results are being displayed, whether they tally with your own result. So it is always advisable to add the solution in excess to see whether they precipitate, they dissolve, or they don't dissolve. If you have access to the Bunsen burner, if you are testing for cations, it is also advisable you can rapidly test, make a flame test of the salt that you have been given to confirm whether the ion you are looking, the cation you are looking for is the right one through your flame test. There are a series of tests that you have to do for cations. That series of tests, like here, you have tests for aluminum ion, ammonium ion, barium, calcium, chromium, 3, copper 2, iron 2, iron 3, magnesium. All these tests you need to be doing as I've told you. Add solution to excess to see the solubility of it. Put down your result, state your result on the observation section of the answer script and try to see whether they tally with the official result that have been displayed on the confirmation section or the reference section on the question paper. That drives out. This drives us to the second section, which is the second section is reactions of anions. Examiners would like to test your knowledge on the carbonates, nitrates, nitrites, sulfides. But of course, these results are always displayed, as I told you, on the question paper. It's not left on you to decide, especially for carbonates. Carbonates, let me say sodium carbonate with dilute acid. What happens is that a carbon dioxide is always released, as I told you. There's a carbon dioxide that is being released. Then how do I know it is carbon dioxide? If there's lime water there, let me make a lime water test. Use a lime water to see if it turns it milky. Let me use a litmus paper to see if it is acidic, because a carbon dioxide is an acidic gas. If it turns red, okay, confirmation of that. You can go to the nitrates if you were to look for the anion, which is a nitrate or a nitrite. All nitrate and nitrite ions, anions. Nitrate or nitrite anions, they give ammonium on heating with sodium hydroxide and aluminum fuel. They will release a gas. So automatically, when you are dealing with nitrate or nitrite in a test tube, and you add sodium hydroxide there, you add aluminum fuel there, and you do the heating, it dissolves. Precipitates are formed. There is fizzing, effervescence. A gas is being released. The next thing is, let me test the gas. If you use the litmus paper and it turns blue, okay, this gas is has to do with alkaline substance, and it's only the ammonia gas that gives that type of color. And you go back to your reference page. Let me see the results for reaction of nitrate and nitrite. If they tally with what the result you have on the reference page, okay, put that on your observation and make your reference maybe ammonia gas observed. You can go to sulfate too, and for sulfate barium, it will also be used for the sulfate and the sulfite. Okay, beside all these polyatomic anions, we can now go to the halides. The halides of these are ions of the halogens. We cannot talk of fluorine because fluorine will not give precipitate. We will only be dealing with the chloride ion, the bromide ion, and the iodide ion. And this, in trying to determine for this ion, which of the anions is there. Let me say we have 3 test tubes, and the solution that is usually used in this case is acidified silver nitrate solution. That is silver nitrate solution and dilute nitric acid. In a test tube, let me say there are 3 test tubes. One contains chloride ion, the other one contains bromide ion, and the other one contains, let me say, this one of the bromide ion, and the other one of the chloride ion, bromide ion, and iodide ion. We have 3 test tubes. Let me put it like this. There are 3 test tubes. One has a chloride ion in it. The other 2 has a bromide ion in it, and 3 has iodide ion in it. What we do now is an acidified silver nitrate solution. Then we add the solution into 1, 2, and 3. Automatically, the silver ion liberated in the reaction, the silver ion will react with the chloride ion in 1, and there will be the formation of a silver chloride precipitate. And those precipitate are white precipitate. It indicates the presence of a chloride ion. In test tube number 2, the bromide ion released in the solution will now react with what? Will react with the silver ion, and there will be what? A silver bromide precipitate. The silver bromide precipitate will be a cream precipitate, cream in color, and that is how you find it on in your test tube. Then in test tube number 3, there is a bromide, there is an iodide ion there. Now we add a silver acidified silver nitrate solution there. What happened? The silver ion in it will react with the iodide ion, and there will be a silver iodide. And it looks what? It is a pale yellow precipitate. With these 3 test tubes, you cannot differentiate that. Test tube 1, which is white precipitate, contains chloride ion. Test tube 2, which is cream precipitate, contains a bromide ion. And test tube 3, that contains with a pale yellow precipitate color, contains an iodide ion. That is how you can differentiate between the halides. It takes us to, from the anions, we can now go to testing of gases. As I told you, when you notice fizz, bubbles, or what we call effervescence, when all this is observed in your test tube, what happens is what comes to your brain is a gas is released. Which gas is that one? Now, you are not going to be testing for all the gases, but use a litmus paper. The litmus paper will direct you which one is it alkaline or alkalinic or acidic. If it is alkalinic, your idea should be towards what? It should be towards ammonia. If it is acidic, it should be towards carbon dioxide. And if it is towards ammonia, if it is towards carbon dioxide, use a lime water. Use lime water to finally confirm the test. If it turns lime water murky, okay. If the white precipitate there or the cloudy solution dissolve with excess of the carbon dioxide, okay. Then in some occasions, you may use the test for chlorine, which is bleaches damn litmus paper. If it bleaches damn litmus paper, okay, then it's chlorine. Then with hydrogen gas, you can use a lighted splint. If you use a lighted splint and there is a pop sound with a lighted splint, a pop sound indicates that a hydrogen gas is being produced. In this case, you will now have to be dealing with cations, where the cations, where let me say a metal is reacting with a dilute acid. For example, magnesium reacting with dilute hydrochloric acid. It is magnesium chloride and hydrogen gas that is produced. To confirm that, it gives you a sound with a lighted splint. Then oxygen will only relight a glowing splint. So if there are gases that are produced, use litmus paper. Litmus paper cannot lead you to the next test to finally confirm the gas. Learners, these are some of the tests you'll be going through when it has to do with inorganic chemistry. On the other hand, there are other tests that you will need to carry out. The examiners will give you to determine the functional group of organic substances. The organic substances could be liquid, it could be solid, anything that they may give you. But they will not identify it. They will only label them as I told you. It could be FA1, it could be FB1, it could be FB3. All those will be the labels. But you are now left to identify which of the carbon compound is that one. And the only way you can identify that will be through the functional group. Functional group test for organic compounds. In this case, we are going to be dealing with. For the functional group, we are going to be dealing with. For the functional group, we are going to be dealing with alkanes. We are going to be dealing with alcohols, aldehydes, and carboxylic acids. That's what the syllabus limits us to. Now let's start with alkanes. The test for alkanes is we use the reagent is bromine water. Let's say we have two test tube 1 and test tube. Let's say we have test tube 1 and test tube 2. In test tube 1, we have an alkane or 3 test tube. Test tube 1 has an alkane, test tube has an alkene, and test tube 3 has an alcohol. Then we add bromine water into these 3 test tubes. Test tube 1 will have no reaction. Test tube 2, there will be a reaction. The color will not change to what? There will be a decolorization of the bromine water, indicating a reaction has taken place. And the reaction taking place, it signifies the presence of a double bond. All alkanes will always decolorize bromine water because of the presence of the double bond. Alcohols in the test tube 3 will have no reaction because there's no double bond in the alcohol. So the decolorization of the bromine water signifies the presence of a double bond present in alkane. Now again, we may go further to test for the presence of the carbonyl compounds. Carbonyl compounds are a carbonyl functional group. A carbonyl functional group is a C. This is a C, double bond O, then is attached to other alkyl groups. So the C double bond O is a functional group that is mostly for compounds containing carbonyl compounds. Any compound containing C double bond oxygen tells you that that is a carbonyl group. Many compounds that contain such of this group are compounds like we will have ketones, we will have aldehydes, we will have carboxylic acids, we will have esters, we will have amides, we will have acyl halides, we will also have quinones. These are some of the compounds that contain this functional group. But our syllabus limits us to carboxylic acids, aldehydes, and ketones. Now, what tests can be used to identify the presence of this organic functional group? Is a 2,4-dinitrophenylhydrazine. A 2,4-dinitrophenylhydrazine is a test that is used for identification of this presence of this compound. Yeah, this is a Brady reagent comprising of methanol and dilute sulfuric acid. Yeah, in the presence of 2,4-dinitrophenylhydrazine, you can identify the presence of the carbonyl group. And all compounds that contain this group in the presence of this reagent will give an orange precipitate. This color you find below here. An orange precipitate. This color you find below here will give that color to you. So now, if you see this color, automatically there is a carbonyl group present there. If you see this color, there is a carbonyl group that is present there. Now, since we are limited to aldehydes, carboxylic acids, and ketones, once you have this one, there is an orange precipitate. It could either be a carboxylic acid, it could either be a carboxylic acid, it could either be a aldehydes, it could either be a ketone. But now, the examiner may want you to really bring out the particular compound involved. So it will lead us to further tests that are being carried out to distinguish between aldehydes and ketones. But now, before that, the reaction that occurs for the aldehydes and the ketones in this reaction are like this. These are some of the reactions. Take for instance, I have an acetone, or what we call propanone, reacting with 2,4-dinitrophenylhydrazine. And we need to have what is the product. I told you the carbon double bond O is a strong polar bond. This bond is highly polarized. The oxygen here is carbon oxygen bond is highly polarized. The same way the nitrogen hydrogen bond here too. In that case, there's going to be a reaction between oxygen and the hydrogen in formation of a molecule of water. In that case, a molecule of water is being released. Under this condition, this is a condensation reaction. A molecule of water is being released, and the product that comes out from here, will be what? The product that comes out from here will be acetone 2,4-dinitrophenylhydrazone. And the observation of this product, of this compound here, will be what? The color observed will be an orange precipitate that is formed. This orange precipitate signifies there is the presence of this bond there. This bond that we have been talking of, the carbonyl functional group, COO. Okay, Should in case we were dealing with an aldehyde, for example, an acetaldehyde, which is ethanol, we are reacting it with the same 2,4-dinitrophenylhydrazine, and under normal conditions, as I told you about the polarization of the bond, will influence the reaction of the bond of oxygen and hydrogen, leading to a condensation reaction, and the product that will be formed will be acetaldehyde 2,4-dinitrophenylhydrazone. The observation of this one is what? It's an orange precipitate color that is observed. This orange precipitate is the formation of this acetaldehyde 2,4-dinitrophenylhydrazone, indicating the presence of this functional group COO, the carbonyl functional group. Now, as I told you, when you have all these having the same functional group, there are many compounds having that aldehydes and the ketone. The examiner may go further to see how can we do this to differentiate whether it is a ketone or it is an aldehyde. Two tests are very, very important. There are two tests that are very, very important. With Tolon reagent, and with Tolon reagent, there are two tests that are very, very important in this situation. Two tests are very, very important. Please. We have the Tolon reagent, and we have the failing solution. Now we have two test tubes for the Tolon reagent. We have two test tubes for the Tolon reagent. One, a Tolon reagent is a silver, is a complex ion containing ammonia and a silver. It's a diamine silver 1 ion. This is a complex ion that is added into a solution containing either aldehyde or a ketone. There are two test tubes. One contains aldehyde and the other contains a ketone. When we add aldehyde into this, when we add this complex, the diamine silver 1 ion complex, which is the Tolon reagent, into a test tube containing aldehyde, what happened in the test tube is that there is going to be a reaction. This solution is placed in a water bath. The solution, the mixture in the test tube containing the Tolon reagent and the aldehyde is placed in a water bath for a period of time. During this period, there is going to be a reaction, a redox type of reaction that is taking place. In the test tube containing the aldehyde is going to reduce the silver 1 ion to the silver metal. And the aldehyde too is what? Is oxidized to the corresponding acid. In this case, is ethanol to ethanoic acid. The aldehyde reduces the silver 1 to the silver metal. This silver metal will appear as gray-black precipitate. Or the silver metal is going to form a coating inside the test tube. We call it the silver mirror coating. That is formed inside the test tube on warming it in a water bath. By doing like that, when there is a silver mirror form, a silver mirror coating formed inside the test tube on warming in a water bath, we say there is the presence of an aldehyde. In another test tube containing a ketone, there will be no reaction. Therefore, only aldehyde will give silver mirror with a Tolon's reagent. 2. If the examiner does not give you a Tolon reagent, if the examiner does not use a Tolon reagent, the examiner could use what we call failing solution. Our failing solution is a copper 2 ion complex. This is a complex ion 2 made out of copper 2 ion. This complex has a copper 2 is made of copper 2, and in that case, to test which one reacts with it, we use this complex ion, which is the failing solution. For instance, we have two test tubes. Test tube number 1, it has a ketone in it. It has a ketone in it. When we place a complex copper 2 ion solution into this test tube that contains a ketone, the blue color will not change. The blue color will not change, indicating that there is no reaction with ketone. Test tube number 2, containing aldehyde. If we place a copper 2 ion complex into this test tube number 2, containing an aldehyde, and place it in a water bath, what happens is that after unwarming in a water bath, this test tube number 2 will do what? Will reduce the aldehyde in it. Is going to reduce the complex copper 2 ion to what? To copper 1. And when it reduces the complex copper 2 ion to copper 1, the color changes. The color change from this test tube 2 will be from blue to red precipitate, indicating the presence of aldehyde in it. Conclusively, we are saying that with failing solution, aldehydes are the only organic compound that will give a red precipitate. Ketone will not. Now, that drives us to the last section of this. But prior to that, let me give you a recap of what we have just done. I said, for functional group, testing of functional group, alkenes, we can be tested using bromine water, and they will dechlorize bromine water. Alcohols, when reacted with carboxylic acid in the presence of phosphoropentachloride, they will also give a misty fumes, indicating the presence of hydrochloric acid, HCl, being produced. Alcohols, phenols, carboxylic acid, when reacted with sodium metal, and effervescence is observed. A hydrogen gas is being produced. You can even test this using, as I said, it will give a pop sound with a lattice plaint. That is a test for hydrogen gas. For carbonyl compounds, carbonyl compounds, I told you, we will use a 2,4 dinitrate phenyl hydrazine. When we do that, all carbonyl compounds containing this will give red crystal, or what we call orange precipitate, indicating the presence of the C double bond O, which is the carbonyl functional group. In that case, it can lead us to differentiate between aldehyde and the ketones, where there is a tolerant reagent, only aldehyde will give silver mirror. Where there is a failing solution, only aldehyde will turn the blue color in the solution to a red precipitate. Carboxylic acid, again, when reacted with a sodium carbonate, effervescence 2 is also produced. There is an acidic gas that is being produced, that is carbon dioxide. You can still test it using lime water. Primary and secondary alcohol, as well as aldehyde, they will undergo oxidation when it has to do with sodium dichromate. Acidified sodium dichromate, that means you have sodium dichromate and dilute sulfuric acid. When you put it into any of this, what happens is that there is oxidation. The oxidation is noticed by a color change from orange to green color when it has to do with sodium dichromate. But if it has to do with potassium manganese 7, the color change will be from purple to colorless. But chloroalkanes, we warm with silver nitrate, a slow formation of white precipitate of of silver chloride, indicating the presence of a halide. So now, after doing a review on what you are supposed to do in the laboratory, on qualitative analysis, you are now presented with an examination question. Because in the practicals, you have about 3 questions. The first section has to do with quantitative analysis, that has to do with a titration, maybe it has to do with enthalpy changes, rate of chemical reaction, and some few calculations. Then you dive to the third section of it, which is qualitative analysis, which we have done a review of what you are supposed to do prior to exams. In the third section, I have taken a past paper question. This is a question that we are going to answer based on our analysis of what we have done. We now apply this on this question paper. I did this in the laboratory, and this is what I have. This is a past question paper on qualitative analysis. The question reads: at each stage of any test, you are to record details of the following: color changes seen, formation of any precipitate, the solubility of such a precipitate in an excess of the reagent added. Where gases are released, they should be identified by a test described in the appropriate place in your observations. You should indicate clearly at each stage in a test, a change occurs. Marks are not given for chemical equations, so you don't need to be writing chemical equations. No additional tests for ions present should be attempted. If any solution is warmed, a boiling tube must be used. Rinse and reuse test tubes and boiling tubes where possible. Where reagents are selected for use in a test tube, the name or the correct formula of the element or compound must be given. A. Fa5, Fa6, Fa7, and Fa8 are aqueous solutions of organic compounds. All of Fa5, Fa6, Fa7, and Fa8 contain carbon, hydrogen, and oxygen only. Half fill the 250 cm cube a beaker with water and heat it to about 80 degrees Celsius. Turn off the Bunsen burner. This will be used as a water bath. To a 2 cm depth of aqueous silver nitrate in a boiling tube, and 2 drops of aqueous sodium hydroxide, and then add ammonia dropwise until the brown solid just disappears. This solution is toluene reagent and is needed in a test in Roman 1. This is the test. As I said, when you have your question paper, read from the beginning to the end where the questions are, so that you will know. It will give you a clue of the type of element, if it is a cation, if it is a functional group, if it is a compound. It will give you when you are answering your questions. When you read it to the end, you will be able, when you are doing your test, you will know the type of test to concentrate and which one to pay less attention. Let's continue. Roman 1. Carry out the following tests on Fa5, Fa6, Fa7, and Fa8 and record your observations. In the table. The test. To a 1 cm depth in a test tube, add a small spatula measure of sodium carbonate. Okay, now it tells you what sodium carbonate can add. Okay, when I did it in the laboratory, there was fizzing. Students could mention fizzing. They could mention bubbles. they could mention effervescence. That was what I observed. I went to FA6. The same thing with FA6. I noticed fizzing. I also noticed bubbles. Again, effervescence. Student can mention any of these words. But with FA7, there was no change. There was no significant change that I observed. FA8, nothing was observed. Then now, after, as I told you, when you notice that there is this, you go for the test of the gas. I went further again. I tested the gas using litmus paper and followed by lime water. I used the lime water. It turns lime water milky. The cloudy white solution, the white precipitate or cloudy white precipitate were formed, or it turns lime water milky. You can mention either you say it is white precipitate that are formed, either you say a cloudy white solution is formed, or you can even say it turns lime water milky. All these are acceptable by examiners. Then, the same thing with FA6. It shows that what? FA5, FA6 have something in common. With FA7, no change. With FA8, no change. Okay, now, I went further. I recorded all this. I went further to the next test. To a few drops in a test tube at a 1 cm depth of toluene reagent. Remember, when they start talking of toluene reagent, some organic compounds should be coming to your brain. Once more, to a few drops in a test tube, to a few drops in a test tube, to a few drops in a test tube, add 1 cm depth of toluene reagent. Place the tube in a water bath and leave to stand. When you have completed this test, rinse all test tubes. Okay, when I did this in the laboratory, with FA5, I observed there was a silver mirror that was formed. There was a silver mirror that was formed in the inside of the test tube on warming in the water bath. With FA6, even though they have something in common with FA5, in this case, I saw nothing. There was no silver mirror that was formed in the place of FA6. Now with FA7, there was no reaction. Again, FA8, this time around, I observed that there was a silver mirror. In this test, FA5 and FA8 have something in common. In the first case, FA5, FA6 have something in common. In this other test, FA5, FA8 have something in common. That should come into your brain. I went further again to the next test, to a 1 cm depth in a test tube. Add a few drops of acidified potassium manganate 7. Place the test tube in the water bath and leave to stand. Okay, as I told you, when it has to do with potassium dichromate or potassium manganate 7, what comes to your brain is what? Their oxidation activity with organic compound like primary alcohol, secondary alcohol, and what? The aldehydes. In this case, in my test tube, what I observed was that since manganate 7 is purple, the purple color on warming changed from purple to what? To colorless, indicating that a reaction has taken place. And in that reaction, all the manganate have reacted. In that case, an oxidation must have taken place. So Fa, in that case, Fa5 undergoes oxidation with what? With manganate 7. Fa6 does not undergo oxidation. There was no reaction. Fa7, there was a reaction because the color changed. There was an oxidation. Fa8, there was an oxidation that took place. So in this other test, Fa5, Fa7, and Fa8 have something in common. Can we now apply it in our question here? Let's go to the question. Using let's use the question here. Using your observation from the table, what functional group is present in Fa5 and Fa6? As we said, Fa5, Fa6, there was fission and there was a carbon dioxide that was present. Only compounds containing only carboxylic acid will give carbon dioxide with carbonates. In that case, my conclusion was that there is a carboxylic acid functional group that is present in Fa6 and Fa5. These are they have in common. Then Fa5, Fa6, using your observation from the table, what functional group is present in Fa5 and Fa6? Go back to Fa5, Fa6. Fa5, Fa6. In Fa5, Fa5, sorry, Fa5 and Fa8, sorry, Fa5 and Fa8. I saw that Fa5, there was a silver mirror that was formed, nothing for Fa6, nothing for Fa7, and a silver mirror was formed in Fa8. Fa8, Fa5 have something in common. It must be a carbonyl group. It must be a carbonyl group, a carbonyl group in this case. So it must be a carbonyl group in this case. But it will not be a carbonyl group in this case because Fa6 carboxylic acid would have been there. So carboxylic acid will be struck off in this case because not all of them having a carbonyl group will give silver mirror. So ketones, carboxylic acid are out. So in that case, it narrows us now to what? To aldehyde. So Fa5, Fa8 will have they have a carbonyl group, but in this case, they are an aldehyde group. But they are an aldehyde compound that are present there. We now say Fa5, Fa8 have an aldehyde group from our conclusions. I mean, our conclusion based on our experiment. So now Fa5 will have an aldehyde group. Then, what type of reaction is occurring in potassium manganate 7? I told you manganate 7 is an oxidizing agent and it will undergo oxidation reaction. In that case, it will be oxidizing alcohol, primary alcohol to carboxylic acid, secondary alcohol to aldehydes. It will be oxidizing aldehyde again to carboxylic acid. Again, it is undergoing reduction because manganate 7 can be reduced to manganate 4 oxide. It can also be reduced to manganate 2 ion. So in this case, there is a redox reaction that is taking place. The type of reaction occurring here is a redox reaction. Both oxidation of primary and secondary alcohol and aldehyde is taking place, and there is also reduction of the compound manganate 4 to manganese 2 manganese 4 oxide to manganese 2 ion that is taking place. Okay, using your observation, question number 5. Using your observation from table, what functional group is present in Fa7? Fa7. Fa7, the functional group present in Fa7. Look at it. The functional group present in Fa7, if you look at it present, from the first test, Fa7 did not do anything. There was no reaction. Second test, no reaction. Third test, no reaction. In that case, it was not aldehyde. It was not a carboxylic acid. But when it comes to reaction with manganate 7, there was a reaction because there was a color change from purple to colorless. Oxidation was taking place here. In that case, it is not an aldehyde because it did not give a silver mirror. It is not a ketone. It is not a carboxylic acid. It will definitely be an alcohol. In that case, it is an alcohol here. It could be a primary or a secondary alcohol that is taking place here. So now the functional group here is an alcohol. The group here contains a hydroxyl group. An alcohol is there because it undergoes oxidation. So now we go to our question. Using your observation from the table, what functional group is present in Fa7? The functional group there is the alcohol functional group, or what we call the hydroxyl group. Now, Suggest a test that would be that would confirm the presence of the functional group in a pure sample of alcohol. Include the result you would expect the test to give. I have tested my functional group to be Fa7 to be alcohol. So now I need to give a test for alcohol or hydroxyl group. There are many tests here. I can use ester test, that's a esterification. Addition of alcohol to carboxylic acid, it give a sweet smell. I could still give alcohol reacting with metal to give effervescence, that is a hydrogen gas is being produced that can be tested. It gives a pop sound with a lighted splint. I could still give alcohol reacting with sodium dichromate, acidified sodium dichromate. Color will not change from orange to green color. I could still use alcohol again plus potassium manganate 7. Potassium manganate 7. The color, there will be oxidation and the color will change from purple again to colorless. I could still use alcohol plus phosphorus pentachloride to give misty films. Any of these tests is a test for alcohol. Learners, you could choose from any of these tests to show a confirmation test for the presence of the hydroxyl group. It takes us to the last section of the question. The last section of the question says, it reads, Fa9 and Fa10 are solids that each contain one anion from those listed in the qualitative analysis note on page 11. That is the reference page or the confirmation page of reaction of anions and cations. It is on your question paper. It is always there. When you do your test, refer to that reference section. Carry out the following test on Fa9 and Fa10 and record your observations in the table. Test. To a spatula measure of solid in a boiling tube at a 1 cm depth of aqueous sodium hydroxide. Warm it. When I did that, I had white precipitate. White precipitate were formed and they dissolve in excess. The same thing happened with Fa10. Then add a small piece of aluminum foil. I did that for Fa9 and I observed there was fizzing, there was bubbles or effervescence. I observed all this in both Fa9 and Fa10. I observed all this in both Fa9 and Fa10. And in doing that, I went further to test the gas as I told you. Test the gas whether it is acidic or alkalinic. I tested it with a litmus paper. It turned the red litmus paper blue. Automatically, it confirmed that there was ammonia gas. And I went back to my reference page. I observed here on my reference page, I went down on the question paper on my reference page. I observed that nitrate and the nitride will liberate nitrogen. I will liberate ammonia gas on heating with dilute sodium hydroxide and aluminum foil. I noticed that only nitrate and the nitride will liberate ammonia gas. So when you do it, always go back to your reference page and see if your result tally confirm. When your result tally, you can go ahead and record them on the observation section. So I did that and I recorded the results as observed. So now I concluded that it was ammonia gas. The same thing for Fa10. They said, okay, the next test, place a spatula measure of solid in a hard glass test tube. Heat gently at first and then more strongly. I did that. On heating of Fa9, the solid dissolved, gas produced, and litmus paper, it turned the litmus paper red. Now, Fa10, I did it, a gas was produced. There was a nitrogen 2 oxide that was liberated on adding on adding dilute sulfuric acid, because dilute sulfuric acid is always used. Dilute sulfuric acid and iron sulfate are the tests that are used to distinguish if it is a nitrite or if it is a nitrate. There was addition of dilute sulfuric acid and the colorless gas turned pale brown in air. Let's go to the question. Using your observation from the table, which two anions could be present in Fa9 and Fa10? From our reference page, you saw that nitrate and nitrite will give that gas. Nitrate and nitrite will give that gas. So the anion present in Fa9 and Fa10 are the nitrate and the nitrite. 2. Suggest a test that will allow you to decide which of the anion is present. Now it is a test to differentiate between the nitrate and the nitrite. State your observation. In the lab, what I did was I added dilute sulfuric acid to a sample of a nitrite, and then I also added iron 2 sulfate solution to the iron 2 sulfate to the solution. My observation was this: there was a dark brown solution that was formed, a dark brown solution or a dark brown gas that was also observed. This indicates the presence of a nitrite. Question number 4, which is the last section. Carry out this test on 9. I carried out the same test on 9. I observed that on 9 and 10. I observed that on 9 there was no reaction. On this test there was no, on 10 Fa10 there was no reaction seen. So I now concluded that Fa9 is a nitrate, and Fa9 there is a nitrate that is there. Fa10 there is also a nitrate that is present in it. These are the answers I got during my lab session on trying to solve this section, this qualitative analysis section. A total of this section is 16 marks. So qualitative analysis carry altogether 16 marks. A recap. Learners, on this section, I am advising you on this section. What you need to do on this section is this. You need, when you receive your paper, read all the questions right to the end, so that it will give you an idea of whether you are testing for anions, whether you are testing for cations, for gases, whether you are testing for functional group, so that you will know where to pay more attention and where less attention is needed. Secondly, you should be critical in your observations, and make sure each observation you see must be stated on the observation section in your question paper. Thirdly, where you observe fizz or bubbles or what we say effervescence, when all these are observed during a reaction, make sure you test for the gas. There are appropriate tests for the gas that are provided. If they are, in case they are precipitate form, always add the solution to excess to determine its solubility if it dissolves in excess. If there's opportunity to carry out a flame test for when it comes to cations, you do it. The same thing goes with functional group. Go the same way in the functional group, test them, differentiate using total reagent and the failing solution when it has to do with aldehyde and ketone. When you carry out all this, follow strict instructions, be critical, focused, and always referring to your reference page. You have all your answers right. Thank you for listening. Subscribe and share to fellow learners so that they can follow up with our future videos. Thank you.